Good afternoon, everyone. Welcome to my EdTalk. Today we are discussing the thyroid gland and its effect on basal metabolic rate. So, thyroid hormones work by binding to receptors on target cells, virtually on cells all over the body. So, they are able to do work on gene transcriptase. Hopefully, you can tell that this is a DNA strand here. It is also able to initiate protein formation. It also in other forms of protein like structural protein, transport proteins. So when there is a slight increase in T4, T3, protein synthesis is able to increase. However, when there is an excessive amount, too much T4 and T3, then it'll no longer be building the muscle, it'll cause the protein catabolism. So keep that in mind. So with an increase in T4, but especially an increase in T3, keep that in mind, we'll talk about that later. It's going to increase metabolic activity. And we can see this in patients by an increased heat production, increased oxygen consumption, and an increased respiratory rate and depth. So the basal metabolic rate can also increase by 60% to 100% above the normal range, depending on the quantity of thyroid hormone that has been secreted. All right, so now we're going to talk about the thyroid hormones themselves. So structurally, the follicular cells are going to be what secrete T4 and T3, and the perifollicular cells, which will be secreting calcitonin. Let's talk about the follicular cells first. So the thyroid gland is going to secrete T4 about 80%, and then the remaining 20% will be T3. So we're going to start with tyrosine plus iodine. That's why iodine is so important in the diet. And once it combines with iodine, it's going to create thyroglobulin, TG. And through peroxidase, it's going to synthesize T4. And then deionization will result in T3. So the deionization process is going to occur in two places. It'll happen in the liver and in the anterior pituitary. All right, and so then T4 is only a quarter as potent as T3, and its half-life is roughly 6.5 days. All right, and then T3 is 4 times more potent than T4, and its half-life is about 2.5 days. All right, so our last hormone is calcitonin. It is going to be, like I said, produced by the perifollicular cells or C cells, so that makes it a little bit easier to remember, C and calcitonin. Kind of makes sense. So the saying for this one is it tones down the calcium. So it's going to do this in a couple different places. So it's going to decrease the serum calcium levels by affecting the kidneys. Pop quiz. Where is calcium reabsorbed in the kidneys? If you said distal convoluted tubule, you are correct. So it's going to cause excretion of calcium. All right, another pop quiz. In the gut, where is calcium reabsorbed or excreted? If you said the duodenum, you would be correct as well. So these two places are going to cause more of an elimination versus a reabsorption because we want to decrease that serum calcium. And the last place is going to be the bones. So this is going to result in increased osteoblasts, so an increased building. The way I remember, I think about this is blast is build. Okay, and so that means the calcium is going to be stored in the bones. And it's going to decrease osteoclast, which is going to be more of that breaking down and increasing the serum calcium levels, where calcitonin will be increasing osteoblasts. So that way we reduce that serum calcium. All right, I hope this was helpful. Thank you.